1, and you take this thing here, let's say we're just looking at the first quadrant, and you rotate it about the line y equals 1. You can transform it, change your variables completely, so that you make this your origin. This becomes y equals 1. But I don't even do it that way because I know I'll make a mistake. But you can, if you change your variables, make this become y equals 1. Everything here will have to change, plus 1.
Let's transform both functions by -1.
I don't know. I never had a good college algebra professor.
For y-axis?
So what you're going to have to do is break it down to element. The way I do it is by doing elemental analysis. Well, let's say I wanted to do. You could say, well, what do you want to do? You want to rotate this about this axis or this about this axis? As you like. So this is y equals x squared. And this is y equals 1. Let's say you want to rotate this about this. I'll do both. This about this. And then I'll take this and rotate it about this. But let's say I take this curve here, this area here, and rotate it about this axis. And look at the volume of the solid thus generated. And the way I do it is I break it up. I say to myself, well, look, what you're doing is you're taking a strip and rotating it about the line y equals 1. And you're going to pick up a pole. Say something like this. This would be my radius. And this would be my thickness. Now, most certainly, you will notice that the radius is a function of x. Volume of this thing. And then I will have to add them all up. Count. Radius is changing with x. This is my radius here. And I will just need to know where I'm integrating from, where to where. Here I'm integrating from to 0, 1. Now I need to know how is the radius changing with x. That will be my function that I will need to square and integrate. How is my radius changing with respect to x? Well, there it is. Who will tell me what is my radius as a function of x? It will be that minus that. That is to say, this is my radius. It's going to be that minus that. This is what? One. This is what?
X squared.
X squared. There is my radius as a function of x. That is to say, I will have to square that thing and integrate it from 1 to 0 and then multiply by pi. The alternative is to change your variables. So my radius as a function of x is, and I will have to square it, is 1 minus x squared. Take your radius and square it. Your radius will depend on where you are. If x is 1, the radius is 0. If x is 0, the radius is 1. And everything in between. And now, you're all experts in antiderivatives. You will say, well, just find the antiderivative. You'll say, well, I need to form it out. And the antiderivative of this is just x minus 2x, 2 plus 3 plus 6, 5, value of 1, value of 0. And subtract. Mr. Harris.
So if the line was y equals 2, would it just be 2 minus x?
Let's do it. The line is what?
2?
What?
If y was 2.
You're rotating about what line?
Y equals
That's a horizontal line, y equals 2.
Yes.
You want to do that? Do it. You just have to think. I'm not going to give you a formula. So, Mr. Harris, you have the area between these two curves, y equals x squared and y equals 1. Y equals x squared, y equals 1. And you want to do what, Mr. Harris?
Rotating.
You want to rotate this or between that. So you know where these two curves intersect. Where do these two curves intersect?
1.
X equals 1.
X equals 1. Sorry.
Now what do you want to do? There are many things you can do, Mr. Harris. The choice is yours. I'll leave it for you to decide what you want to do. You have this line y equals 2. What do you want to do, Mr. Harris? Tell me and I will tell you how to do it. Yes. We have this thing. we have this thing, we have this line. What do you want to do?
The first option.
You want to take this
Yeah.
and rotate it about here?
Mhm.
Okay, that's his choice. He wants to take this area here and rotate it about the line y equals 2 and find the volume thereof exactly. I'm gonna have to make it a little smaller, huh? I'm running out of space here.
Just take two and subtract it.
Yeah.
Take the radius of whatever it was that you found there. First one minus that square. Then you take 2 minus that. And then that would be your radius. Because then that would give you just that. Which is. But you take 2 minus, in brackets, 1 minus x squared. And that's your radius. Yeah. Yeah, I think that's
The volume of that, Mr. Harris, is that correct?